now we can get going on the show and tell. So could I have a show of hands for people who want to show something? Okay, so I'm going to kind of sweep across from right to left, and then when we get over there, we're done. So who's going to start first for us, or?
I actually need to set up.
So start setting up. Okay, Tim.
Okay. My exercise. For those that haven't seen him before, this is my robot Brutus. It's still a work in progress. And it's scarlet and gray, not red and gray. And since the last time he appeared at the main meeting for show and tell, we've added this tower and the Asus XTN Pro depth camera. And in the process of getting this all put together, I got checked out on the 3D printer at Tech Shop. So these white plastic parts holding it down and these brackets holding the tower down are 3D printed. So far, I've got the motors to turn under computer control, which is a big plus. I'm about to hook up the encoders, and once I get that done and it works, then we can start moving on to getting the whole thing controlled and running along. Cool.
Okay. It doesn't look like Force is ready. John?
We got the club bot, and it took us like 3 weeks to realize that we weren't doing it right.
Yeah, the SIG meeting was really great, and Ralph, helped us get into like the bash file and change the right address. And then after that, it got a lot easier, and and now we got the tele-op working with the help of Tony.
Yeah, Tony helped us get the tablet to work. It's pretty fun to play with. We have too much. Our house is pretty small. We were messing around in the room, and we forgot we had a cat in there, and so like we're still trying to get him from the ceiling.
Yeah, he does not like this total bot anymore. He likes the box.
But for overall, once you understand the language and everything, it is pretty easy. We're right now trying to get the Connect to work.
Yeah.
For us, the main thing was just actually getting it to run.
We got the
from
dashboard
computer,
up and the terminals.
and we were just having a lot of fun until we figured out how to get to the IPs and stuff like that.
And then the concept of having a terminal open to run each function.
You're not getting a picture? You're not getting a picture?
Right, we're not getting a picture yet, but
No.
but we're losing connection with the Connect, and then
Once again, it's a lack of.
I think it's the Wi-Fi is slow.
We don't have to debug it now.
No, it has nothing to do
We
with
got
that.
it moving in a month.
No, it took us a while to get it.
It was hard enough.
The next question is, anybody interested in playing with it next?
Yeah, so this is our club robot that was donated to us by Will Garage. Thank you very much, Will Garage. And the way this works is it's checked out to members for 1 month intervals so that they can learn basically ROS and TurtleBot without having to lay out big bucks to do it. And then what's happening is this is motivating a lot of people to go try and build their moral equivalent of a TurtleBot. And my goal is by the end of the calendar year to have 10 TurtleBots running in the club. I think we're going to meet that quite comfortably. Can I have a show of hands of how many people have got their TurtleBot things going? Okay, 1, 2, 3, 4. We've got more than that. So, anyhow.
What do you mean by going?
Moving, running ROS, that's all.
But all seriously, we figured that it would only take us a week or two to figure out how to do the Connect. It was our fault that it took us so long to get it to work on the actual computer and the pad. So
We're also talking like it'd be better probably to hand this over to SIG when someone can give you like an hour of pre-tutor training.
just give you an idea what's
So you
going.
can get your files set up.
That's actually
It
a
took 3
really
weeks.
good idea.
It took 3 weeks for us to just, once we got it to SIG, within an hour we were running. But
Okay.
the 3 weeks.
I'm going to propose that we actually take that advice and we'll hand off the robot during the SIG.
Okay.
And then we'll get a full month with use, and then we can
And
maybe
then
connect,
that,
and then.
because you're running it that night, we're no longer wondering what's going on and looking
Right.
on the message board and all that.
Okay, so I'm going to propose that you guys hand it over at the next SIG.
All right.
Okay?
Okay.
Now, we're going to have to figure out who's going to get it next SIG,
All
but
right,
that's the way. Now, who wants to take it next time? Chuck, it's yours. Okay, Who's next? You ready, Boris?
Yeah.
Okay. Here comes Boris.
Okay, so I have been playing with Ross and the Nito node and the Nito drivers, and with some help from people in this club, I wrote a node.
Yeah. Do you think we could lift that up? Or some?
Yeah.
Could somebody? Thank you, Bob.
I wrote a node with some help in C++ to drive around with a joystick. And that really helps mapping because driving around with the keys is really annoying sometimes and you crash into walls and stuff. Yeah, and I got a map. Well, I don't have a map yet, but if I drive around, I'll get a map. And I've got actually RViz running right now. So if I drive around, I can get a map and then I can show it to you, connect the laptop.
You have a camera on there?
No, it's a
You can use laser?
laser, yeah.
That's an XV11, which has the laser triangulator.
A really cheap laser, actually.
Well, let's not complain too much.
That's a compliment, Lance.
Yeah. Okay. Good. Okay, how are we doing on the hands? Let's see that, the hands again. Have we more or less cleared out that corner? Okay, Ted?
Set up first.
You start setting up, Ted. Tony?
All right, so most people, we have power?
I don't know.
Yes, we don't have power. That's messed up.
There's a socket there.
There's a socket
Okay.
way over there.
Okay,
Direct your attention over there.
so many of you, does everyone here know what the Robo Magellan contest is?
Well,
Does anybody not?
Robo Magellan is basically building robots that can navigate exterior terrain using GPS and other features, just so you know.
So, what I have here is my new Robo Magellan robot, Pogano Myrmex occidentalis, the Western harvester ant. And this is one of the first of our mini phone-controlled robots that we're demoing today. This one is using a Motorola Droid Razr Android phone with the USB drivers from FTDI to talk to the propeller, which is controlling the RC car and reading my sonars. So right now I have the Android app working where I can go in, and if I put in a large enough number, okay, never mind, battery problem right now. But I do have sonar data, which you can't see, but yeah. And basically, it's been a real adventure, as you'll hear from our other cell phone-based robot presenters tonight, about interfacing cell phones with the robot. This particular one involves using a USB host cable, a powered USB hub, and a spliced USB cable. Don't ask why.
Hack it till it works.
Yeah. And that's about it. The advantage of these phones are great because they have GPS, they have compass, they have accelerometers. They basically, and they have cameras that are really good. They basically have everything you want on your robot except for your robot in them. And so I think really this is a great way to go. Yes, sir.
Does the phone tether to the robot, is that tethered securely enough to count as like the cutoff for Robo Magellan?
I'm actually, the phone's going to be mounted. I have a thing here just for now. The
Okay.
phone actually mounts on the robot.
Uh-huh.
I guess you could use the phone's Bluetooth to like another phone as a switch. I just stuck the thingy from the RC car in there and wired it to the thing so I can have like RC car switch turned off. But yeah.
What bridge board are you using?
I'm using a propeller.
Okay.
I've just got the
What-
propeller
what for
education
the,
kit.
Provide
and-
USB host.
What?
To provide, what are you using to provide the USB host?
I just have the Motorola phone hooked up to the on-the-go USB adapters, ones you get to like plug your mouse into your tablet or something.
Oh, okay.
And then that's connected to a
Yeah.
USB hub. The thing is, it's actually kind of weird because this is running Android Gingerbread, which usually doesn't have a USB host controller in it. But Motorola has this weird custom laptop thing, which makes it actually work as USB host. It's really weird.
Let's not drill too deep.
Let's take that one offline. If
Yeah,
you want to
thank you.
hear about why this works, let me know.
Okay.
This would be trivial on a Samsung. So,
Okay.
all right. Motorola Droid Racer.
We'll go to the next one. Almost, but we'll go to the next one. Next person I think is Hal. I should comment that I am going to be starting a robot startup, and this is my co-founder, Hal.
This is not a robot. This is, as you can see, very lightweight, and you're going to have to stand up to watch it unfold. Personal urban transport that I haven't used a lot. That goes about 10 miles an hour.
What was just the weight?
About 20 pounds. It's got foot pegs too. The question is, how do you, with all the intellectual horsepower we have here, how do you make it autopilot? Now, just so you see a couple of the unique features, right? It's got turn signals, a horn. Whoops, there's the horn. We'll do that again. Right? And then, whoops. It's got electronic braking, and then it's got brake lights. So, while, again, this isn't a robot, but we thought it was so cool that
How long does the battery last?
about 6 miles. 20 pounds from a company in New Zealand called Yike Bike. YikeBike.com.
How long does it take to charge the battery?
55 minutes.
Okay.
And then
Those are commercially available?
commercially available.
At what price?
Expensive.
You have to ask.
Well, the aluminum version is $2,000. And this is a carbon. This is a carbon fiber one. Any other questions? YikeBike.com.
Yeah.
So, thank you. You guys ready?
Yeah, we're ready.
Okay,
So,
our friends at Ologic, do you want to pull the tablecloth a little more centroid? So. Yesterday, I got a message from Bob here saying that they had their Kickstarter ready, and this is what it is. I'll let them take over.
So this is the robot that we've shown at the club before. It's basically a smartphone robot that runs on Android or iPhone, and there's two different versions. They have one that has tracks and one that has wheels, and it can get up and down. So it can, and it has a little personality that runs on it. And let's see, earlier this month, there was an email that went around about a cloud robotics hackathon. And I think Ryan sent it to me, and he said, "Oh, I'm going to go to this thing. You guys should go." Right? And then you didn't show up, right?
It worked. I got you to go.
Yeah. So we went. And the deal was that if you went to this cloud robotics hackathon, it was put on by myrobots.com up in Montreal, and this robot launchpad group helped organize running one here at the Citrix Startup Accelerator, and there was about 13 teams that showed up. And the deal was if you registered by a specific date, which I think was the 15th of February, you got a free robot, okay? And it was like a Wi-Fi capable free robot. It had Wi-Fi, Bluetooth. It was like this track vehicle. Did anybody bring one that was there? No, I don't think so. Okay. So 13 teams showed up, and you basically had 48 hours from Friday night till Sunday at 1 in the afternoon to take a robot and make some cloud app that would work with the robot and give a cool demo of it at the end of the weekend. And so we had a robot, but it wasn't cloud enabled. But we're capable of making it do that. So we thought, well, we'll take our own robot and cloud enable it and make it do something cool. So I guess on Thursday we sat down and we said, oh, let's make it play tic-tac-toe as like a virtual avatar. And then Friday we showed up and got cracking on this, and by Sunday at 1 it was done. And we had it working, and we actually won the Santa Clara Regional with our thing here. Yeah. And it was run by this group in Montreal, which is the Robot Shop, and we took second place in the world. So the first place winner was in Montreal, and her entry was really cool too. It was like a math quiz thing on a tablet, and the robots would go all ape if you got the answers right and wrong, and it was pretty neat.
Measured your brain power.
Oh, measured your brain power, right. So the idea is there's an application running on the tablet here that I can use to play the game of tic-tac-toe. And
I might have moved it off.
yeah, you set it up there. It's gonna get on that line at a weird angle. We kind of ran into some issues where the edge of the table was kind of a little too close to the lines. So we built a line sensor to add to the robot so we can do line following. And then Brandon came up with, at the last minute, on Sunday morning, bright and early, he came up with a planner and a path planning algorithm that could figure out how to get to any point from any other point on the game board automatically. And so, you want to make it go? Or
Right.
say
So
anything about it, or-
does this starting location look right?
Yeah, looks good. Fire it up and then we'll make it play the game. It doesn't always work perfect every time because, believe it or not, we did build it in 48 hours. Oh.
This is part of.
Okay, so it's articulated, it can get up and down, and it actually has independent limb movement, so it can dance and stuff too. So now it's ready to go, and we need to pick a place on the tic-tac-toe board where we want to put the first X. So I don't know. We'll just pick a spot. You want to put it? We'll put it in the middle. I guess. Okay. So I'm going to pick the middle, and when the X goes to the middle, then it goes up to the cloud, posts the X to the cloud. Oh, now the robot knows. It talked to the cloud and knows the X is going to go to the middle square. There you go. And it kind of gives some feedback to tell us when it's moving along the little track that it knows where it's going.
So every intersection it gets to, it does a little audio beat. So we know that it knows where it is. And then the phone tells the robot base, the next road to take, basically, to get to the destination. So in this case, the center blue square.
Right. So all the path planning and cloud talking and all that's running on the phone. And then cool. And we could sit there and play a whole game, but we won't.
It'll take a while.
Thanks.
folks want to mention about the Kickstarter?
Oh, yeah, so this is a robot that we've been working on for about a year, and we redesigned it a couple of times, and finally we're pretty happy with this design. It works very well. We also have a version of ROS that's using ROS Java that will run on this thing, and we're also working on porting ROS to the iPhone as well. So we have Kickstarter relaunched. What?
You've got ROS on the Android phone?
Yeah, we have ROS running on the Android phone, and it's it's not just a ROS node, but it's a ROS master too. And we're using the code base that Ryan's team started with, which is the ROS Java code base. And we have a ROS node for this robot. So you can literally like go into RViz and dork around with the robot and everything, and it'll just do it. So we're actually working on bringing the 3D models and everything in as we speak. But we launched a Kickstarter to get these tools so that we can injection mold the plastics and everything and sell a bunch of them. And we just launched it yesterday. So it just got going. So if you like this robot, you think it's cool, go to Kickstarter and do a search for Oddworks. That's ODDWERX. And it's up there, and you can buy one for $99.
Last time I checked, you were $1,000 on the way.
Yeah, actually, like 3,000 now, I think. Yeah, I just looked at it a little earlier. So.
Okay.
Good, cool, thanks.
I think I've covered that side of the room, so there are a few hands over here. You.
My name is Jonathan Van Dyke. I'm new to this whole robotics scene. Well, I guess I came to a few meetings like a year ago, so this is kind of my first meeting again. But I've started putting together this little tabletop robot that I want to put inside the tabletop challenge that the new robot people get to do in a couple months. It's just running off an Arduino processor. I've got two little GM9 motors and an H-bridge that I've got from SparkFun, a little breakout board, and then I wanted to mess with the little shift out register so I could see how that worked, and it turned out to really clean the code up because I can just put in like a single 8-bit number, then that's translated into binary, goes in, and then based on the pin output, will make my motors go forward, backwards, or slip turns and spins and things. So I've been having a lot of fun. This is my first experience with programming, so I've been using the Macomb article from Servo from a couple years ago. I got a subscription and printed all that out, and it's really been helping a lot. So I've been having a lot of fun with it. At present, all it can do is detect edges on the front, and it kind of stops, so it looks like it's thinking for a second, backs up, and it'll, go on its way.
Good. You got challenge number 1 done.
Does it move?
Yes, it does. It works. Would it be okay if I used your table?
Yes.
Yeah. And I'm running it off of 2 lithium batteries. And I have a voltage regulator for the motors to down volt them to 6 volts. And then the Arduino has its own onboard voltage regulator, so that works pretty well.
You have a lot of faith in that robot.
Yeah.
Well, actually, I was up pretty late last night because I had some stuff mixed up, and I was like, oh no, this is going to work for tomorrow. And then this morning, I got it all fixed, so.
All right.
Will it work if the table is like really low to the ground?
Uh,
Like if it's sensing like the edge?
Good point. So right now, I have it set pretty based on kitchen table height.
Right.
So if I believe it's anything less than 300 out of its, like it doesn't use the, what is it, the full range on these? Yeah, it's like 50% of its max range is considered too far. So
it might go off a sidewalk curb or stair.
yeah, so like, well actually, if you turn it on, and then if there, that's about how, that's anything, that's all it needs, and then it picks it up. So I guess it's a little closer than I thought. I haven't done the distance calibration, but I figured if, I didn't have time.
Where did
that took me, I looked all over the place, and there's this, I finally found it, and then they're like, we don't make them anymore. So there's this new, it's a Micro Atom, that website has these neat little tracks that they've picked up by, I think the company starts with a P. I'm sorry, I don't know exactly.
This is not the Gordon Budget Robotics, is it?
No, these are different. So I wanted to use something different than, Gordon McCombs recommends using the continuous servos, but I wanted tank tracks so it could crawl on stuff. And I think what is it?
Pololu.
I think it's Pololu, or so yeah, I think it's their tank tracks. They have a nice, like, it's a little more rubberized, so it goes on the smooth surfaces a little better than I've heard some of the other tracks do.
Okay.
So,
Very good.
yeah, thanks. That's all one more hand.
Thank you. Backtracking, do you have a robot?
Yeah.
Okay, come on out. You've got a robot too? Okay, him first, then you. This looks cool.
See if I can talk today. So, last year we participated in RoboGames with our micro mouse, and we saw that MechWar thing. So we thought, that is cool. We can do that. So we started to build a kind of humanoid thing. And the idea here is that usually the way you do humanoids is that you have 5 or 6 servos per leg. And we thought that is way too much, because we need to move the leg just in 2 dimensions, assuming that we have a flat surface to walk on. So we actually designed this thing to work on 2 servos per leg. And yeah, we didn't make the whole thing to participate in MechWar, so we think we will just do stair climbing. But yeah, we still have a month to go, so it should be
Tons of time.
yeah.
So, what is the technology you used to make all those parts? Just drill press or
Yeah, micromill.
a micro mill? Okay.
Yeah.
Okay. Well, thank you very much.
Needs no introduction.
What?
Needs no introduction. I've had it 2 weeks. I wanted to give credit to a couple of folks that helped me at the SIG last week.
Excellent.
Ralph, and the 2 of us can't remember the other person that was helping me a whole lot and got it to at least bring up, with several error messages, of course. But after all, I only just got the laptop that afternoon, so I suppose that's fair.
Well, your timing was good.
And finally, I wanted to just to give an acknowledgement to Alan's article, which has been, in spite of about an inch thick of stuff from Ross, was invaluable in actually solving a couple of problems. So I'll look forward to at least buttonholing you, and thanks. I have to say, when I put this together, I'm now retired, but it actually takes me back to sorry to be a little bit nostalgic this way, but I kind of remember when my father gave me for Christmas a soldering iron when I was 10. And my God, now look what I've done. Anyway, whole lot of credit to the Willow Garage. It's fabulous, just what's there, what they've done, and what the community they have collected. And I'm certainly going to look forward to making it work, actually.
Excellent.
The batteries are all charged, but it doesn't do anything other than
Looks like
blink
it's powered on.
and send error messages. So anyway, I least I did want to
Thank you very much.
say a few words.
Okay, I think there were one or two more left over here. Camp, anybody else? Okay, it looks, oh, nope, we got one more there. So, why don't you, are you ready? Come on up.
It's a robot that is supposed to walk like a bug, and there's lots of gears that make it work correctly, and the claw opens and closes.
Just want to go right off the table, too. That's great. Excellent. Have you named it yet? No name yet.
I thought you called it insect bot or something like that.
Oh, well. Okay, Camp, you're on.
Okay, this is my Robo Magellan robot, Blue Dog, and I went to, we went to, had a Boy and Girl Scouts, 200 of them, on Sunday. We did a robot show and tell, and it was awesome. You should take every advantage to demonstrate your robots, because this makes you prepare them. This robot, I had forgotten that when I last worked on it, there's a bug where you had to program the GPS at the last minute. And then I don't know, it starts communicating. But regardless, most of you know my spiel on Robo Magellan and GPS. So I won't go through that again. Regardless, I was so excited because when I loaded the GPS code, Blue Dog sprung to life. I didn't have to do anything. It's not working now because it's not getting a GPS signal. In fact, if you'd started at the other end of the room, I was getting a GPS signal over there.
I'm really
Regardless,
sorry,
you got to
Camp.
play them where they land. Right now, it's just reacting to his bump sensors. What it'll do is, if you have a target GPS coordinate and an actual, you can determine your bearing. And Blue Dog turns clockwise until it's headed in the right direction, and then it goes forward, avoiding obstacles along the way. So on a good day, I can actually get to a GPS coordinate, and one time at CMU, I actually accidentally touched the orange cone, so that was great. Like I say, we've got, I think, a dozen Robo Magellan contestants at Robo Games, so it should be a lot of fun. Thank you very much.
I want to thank everybody. We had a lot of robots tonight, and we had a lot of Cub stuff, and we managed to get it all done within about the 1 hour that we allocated.